Just got a couple of section announcements. Our next talk is going to be first Thursday of May, which just need to double check. I think it's the 2nd of May. Phil Singleton from Network Rail is going to be presenting to us on Midland Rail Hub. That is going to be an online only meeting. Yeah, we'll obviously send some details out about that nearer the time. We are also still recruiting people to join the section committee. As I've said quite a few times in our meetings, it's a role which doesn't really require a massive amount of time, but gives you a really good opportunity to get involved with the committee, influence the kind of presentations, site visits we may be having. And yeah, as I said, it doesn't really take a massive amount of time, just a couple of hours a year, really. If you are interested, please send an email to Cheshire at pwi.org, and I can give you some more information about the positions. So yeah, to introduce today's speaker, we've got Steve Richardson here today from Alan Griffiths, who's going to be presenting to us on Barmouth Viaduct. Really happy to have this one today. It's great to engage with the North Wales area, obviously being part of our section. Did you want questions before? During the presentation or at the end? Or
I think, given the problems we're going to have in the presentation, I suspect probably the end.
Yeah,
might be best suited.
So yeah, as out on the call, as you can tell, we're obviously recording the call. So if you can just make sure you stay on mute and have your cameras off. And I think Steve will be taking any questions at the end of the presentation. So yeah, thanks for coming, Steve. I'll hand over.
Yeah, no worries. Thank you for that, Pete. So as Pete said, I'm Steve Richardson. I work for Griffiths Contractors. I've been on the railways for 30 years this year, come September, for some strange reason. So yeah, I was the operations manager for the timber viaduct, the timber section reconstruction, or refurbishment would be a better description. And then I moved across to be the engineering manager for this. And then step back into ops manager just now at the end now, just to basically take all the glory, to be honest, or to finish it off as we think. So I'm just going to run through a very quick project overview in terms of what the scope was, what we needed, the specific challenges and solutions. Can I just ask, can everybody on back on Teams hear me correctly? Is it coming through okay? Thumbs up or something like that would be ideal.
I think we've had a wave. I think Carl's waving. Yeah, I've got a few thumbs up.
Excellent. Yeah. And then, so I'm going to run through the particular challenges that we had, how we decided to get around those, and then I'll run through certain aspects of the methodology, which includes animation, which is we had animation developed both for the tender, then for planning, and then for public consultation, and finally for briefing the operatives on site as well, in terms of what we're going to do. And the video, which by the sounds of it, I'm going to have to apologise for now, because I suspect it may not run quite the way I want it to, but it'll hopefully give you a pretty good feel of what we did. So the viaduct itself, it was first opened in 1867. It was originally designed by Henry Conybeare and Benjamin Percy. It didn't look like the structure that we see today. It was actually a drawbridge, short section for the navigation span. In 1902, or 1899 to 1902 to be more precise, it was rebuilt into the structure that we see now, which incorporates the swing span. A few minor interesting bits from that is that the original piers 1 and 2 are from the very original 1867 construction. The other piers 3, 4 and 5, 3 being the one that supports the swing span there with the 4 columns, 4 and 5 after that, and then leading up to the timber one. They were brand new on a slightly different alignment to the original one. And that's significant because, and hopefully that can be seen relatively easily, these 2 beams here are there specifically because the alignment of the main girders compared to the cylinders is offset for those 2, because they changed the alignment when they did the reconstruction, and that causes its own problems later on from our point of view in terms of how we actually reconstruct those elements of the bridge. It's an iconic railway. It's Grade 2 star listed. It's Grade 2 star listing actually comes from the timber section. As it says there, the only major timber built viaduct still in use in the UK. There are other timber structures, all of which are in Wales, 9 of them in total. We've worked on quite a few of those, to be honest with you, alongside this one. And just a quick explanation of what the bridge is. The 2 flat sections that you can see here, closest to us, they're Bridge 42. Actually, the entire structure consists of 3 separate bridges. So Bridge 42, which are the 2 flat sections, Bridge 41, which is the hogback arches, which consist of the swing span, which used to swing up until around about the 60s or 70s when it was no longer required for passing of tall ships. And then the fixed span, which looks basically identical but doesn't swing, hence the name of it. And that's relatively relevant because I'll make reference to those things as we go through. Just a note there that's mentioned in passing, the 1902 version of this bridge was actually built by Cleveland Bridge from Darlington. When we originally tendered the works, Cleveland Bridge were our chosen fabricator. So when we were awarded the contract, they would have been rebuilding the bridge that they built back in 1902. Unfortunately, within about 2 months of contract award, they went into administration. As a result, we ended up building it with Carver Engineering Services over at Doncaster, which plays part of some of the temporary works that I talk about later on, because a lot of it was going to be done in Darlington. So the scope from Network Rail was relatively straightforward. Full superstructure reconstruction of the metallic sections, full track realignment over the metallic sections. We were basically given the design as a Form 1 or Form A, as we're now reverted back to. And the main reason for the realignment was the fact that we had to lift it by approximately 180 mil above the swing span Pier 3. And that was just by virtue of the new support mechanism that went in there, taking away the ring mechanism. Change of longitudinal timbers to direct fastening. So we put Vipers down onto steel stools for the new design. And we also were commissioned to do the design and follow it right the way through another 300 metres beyond the end of the north abutment, right the way through the tunnel for works at Colas, then installed immediately after we finished the bridge reconstruction. We're also commissioned to paint all of the piers, including replacement of the bracing steels. Initially, we weren't down to replace the horizontals, but through inspection, we then agreed that we would change the horizontals. Interestingly, we then reverted back for the very lower ones, because the lower ones that don't come out of the water very often were actually in very, very good condition. So we left them in, largely because it was going to be very difficult to change them, and secondly because they were in actually reasonably good condition. And we also changed the marine lighting for a like-for-like modern replacement. The other significant scope change, if you like scope change, the original bridge, and any of you who have been lucky enough to walk across it may recall, the handrailing on the bridge, on the metallic bridge, is actually a highway style handrailing. So you've got vertical steel members there, with some money from the Railway Heritage, and with quite a significant input with CADU. They changed that to a post and rail arrangement, a post and tube arrangement, basically, which mimics as close as they could find out probably the original handrailing that was on there, and it was a fantastic thing that they did there. The other thing as well is that because it's Grade 2 star listed, there was an awful lot of third-party stakeholder involvement. One of the significant outcomes of that was an insistence that we put fake rivets on the top flange of it itself. So the new bridge, and if anybody goes and visits it afterwards, and hopefully you can pick it up on some of the photos, has 3,000 fake rivets across the top flange. Most of us myself included, kind of shook our heads initially at that thought. But when the first time I seen the bridge for the trial erection in Carvers, unpainted for that matter, with the rivets on, it was very clearly the right decision. Had it gone back without them, it would just not have looked right at all. It's quite crazy that that's the situation that we're in. So the bridge itself sits in tidal estuary off Mowdach. I'll never say, I'm not even going to attempt it because I'll insult anybody that's Welsh. You've got a tidal range of up to 5 metres on spring tides. Parts of the structure towards the timber section, so Pier 5, the fixed span, often dry out at the extreme tides, whilst the navigation span never dries out. So we've got a combination of sometimes having water on bits of it, and some at the same time not having water underneath other bits of it. The entire area is triple SI, so that brings its own issues. Originally, part of the feasibility, and I was part of the feasibility before we even tendered for this scheme, we considered a causeway. That was pretty much dismissed due to the fact that it is triple SI, due to the fact that you've got that 8 metre range and the impact that it would have had on the tourist town of Barmouth. Because obviously, well, not obviously, the work was actually carried out over the winter period. So we started at the beginning of September, autumn period, beginning of September into December for the main blockade, purely to minimise the disruption for the tourist trade and such like in Barmouth. But if we'd have done a causeway, we'd have been building that at the height of summer leading up to that, which would have been a particular issue. So that was dismissed as a result of that. The next obvious thing, when you've got a tidal estuary there, would be to work from the sea. So we could all work from pontoons, large pontoons for cranes, and actually bringing the completed bridges in or the old bridges out. That was dismissed largely because of the tidal range, but also the nearest port that we could bring it in from was Holyhead, which is about 18 miles by sea. And we'd have been bringing it in autumn winter, which is notoriously going to be bad. And we would, we have to have near perfect conditions to bring it that type of distance. And the tidal range causes us a problem because sections of it would dry out, whereas sections of it would still be thingy, which would cause a stability issue. To get round that, it's quite simple. You would use a spud leg pontoon, bring it in at high tide, put the spud legs down, just to throw something else into us as well. We've got a 33 kV cable under the seabed there, which sits about 20 to 30 metres off the structure, running parallel with it, right the way down there, which is pretty much exactly where you would want to be putting the spud legs. So we'd have had to have that diverted as well, which would have been quite a bit of an issue. Obviously, access for large plant, very difficult. One of the other things, as we developed the design at tender, or the initial ideas at tender stage with TGP, our designers, they had concerns over the stability of the piers, in particular piers 4 and 5, which are the most southern ones, largely because there is very little information about them. They know that they go very deep and they simply rely on the sand around them, and their concern was proving lifting the deck off them and then not moving. So whatever solution that we had, whether it was what we ended up with or something else, we would have had to find a way of stabilising these two piers. As a minimum, these two piers. As it happens, piers 1 and 2 were also questionable, which we did find a way around that as well. So the solution had to address all of that. Additionally, which I never put on there, there's a FTN cable that runs across the bridge. One of my network rail colleagues, I was going to say there, but still, described it as the M4 of information for the area. So there was no diversion going to be happening to it, so we would have had to find a way of supporting that in situ for the entire time. So couldn't crane it in by sea. We had to maintain stability for the piers. So we decided to bring in pretty much everything in terms of the new, to a degree at least, by rail. We've got a perfectly good railway system there. Our site compound, which we already had for the timber refurbishment, is a straight track straight to the bridge from north of the Barmouth Viaduct station. So we decided that we would bring everything in to avoid any waterborne cranes and such like. What we decided to do is bring in the 2 hogback beams, adapt them with a series of temporary works to create an 85-metre long runway system for a gantry crane. That gantry crane would then be used to demolish the existing bridge and be used to build the panel sections of the new bridge. I'll explain more as I go on. So when we did the demolition, we literally cut it into 23-ton sections. They're approximately 4 metres linear length along the bridge, 8 metres in plan, and we dropped them down onto pontoons, simply plastic pontoons. Basically, it's a little bit of an adaptation of that. It's a company called Scaflow, and they provided those. We literally dropped them down onto those and took them to a nearby beach. The advantages that we had with this is that the system, as designed, maintains stability for the piers, because at no point did the piers not have a span. At one point they had 2 spans, obviously the old one and the new one, and then as we demolished the old one, they had that fixity from the new span as well. For piers 1 and 2, TGP were concerned that they couldn't prove that they would stand and not move. So we had a very elaborate system between the abutment, Pier 1 and Pier 2, to hold those in place. You can probably see from the drawings and from the sketch above there that Pier 2 did have the new bridge and the old bridge, the swing span bridge, actually on it. But the reason why it still needed the support there is the way that we ended up changing these crosshead members that I mentioned before that were there because of the change of alignment in terms of the bridge. So we had to develop a rather clever system of changing those. So we had a strutting system for those. We also needed rock anchors into the abutment, so we doubled up with those rock anchors in so much as that they were used not only for the permanent arrangement but also for that temporary works. So the pull-out force that we needed to resist in order to stabilise Pier 1 and 2 was used for those. Bridge 42, which as you can see here, which is the northern flat sections, we used a slightly more traditional, if you like, approach for that. We used a crane on track to basically build that, to demolish that and rebuild it. That wasn't straightforward either because it didn't have the reach to reach Pier 1, but I'll explain what we did for that a little bit later on. Of note, there is 50 significant temporary works elements within the scheme, and when I say significant, I don't talk about fencing or hoarding or minor little pieces. I mean, there was temporary works to put temporary works in at certain stages with it as well. Just a thing. You know, I'm talking about, you know, the gantries, the runway beams, the beams underneath that spread the load from the new beams in their narrow positions down onto the cylinders. Temporary works to change the bracing of the actual piers themselves. An awful lot of temporary works involved in that. So, to get the hogback beams, which are 40 metres long, to the bridge, we adopted a Unimog, which is perfectly capable of pulling 600 tonne. This unit, as it stands, as you look at that photograph there, is circa 200 tonne, just shy of 200 tonne that we brought it down in. We brought that down on 6 trailers, 4 40-tonne trailers and 2 20-tonne trailers. Each one of them had their own bespoke piece of temporary works on it to spread the load back directly into the axles from the pickup positions that were obviously dictated by the actual bridge itself and the nodal points within the bridge. And almost as a suspension system, to be honest with you, we had 20-tonne jacks, so we had 20-tonne jacks along the system, and that was used to basically stabilise the entire structure as she ran down to the bridge. You've got to bear in mind that we were running on existing track. Now, the existing track on the timber structure was actually in pretty good condition because we'd only renewed it 2 years earlier, a year and a bit earlier actually, to be perfectly precise. The section between our compound and the bridge had actually been down for a renewal, but it hadn't happened, it had been cancelled. So we were running very much on the existing track. One of the concerns that we had with that is you've got a 40-metre long, very straight bridge, and you're running it along what should be straight track, which it never is particularly straight track. So we had a full versine check at 3-metre intervals using a 40-metre versine all the way through to see if we were going to have any specific issues with the trailers. Because if you imagine you're going straight, the trailer's underneath, the track moves left to right, the trailer will want to stay straight because of the way it's connected to everything else above it. If it stays straight, it will keep straight and it will just simply derail, which was a genuine concern that we had. We established that we were definitely going to have a problem. I think it was about a 20 mil problem, just as you approach the bridge. We got round that. We got round that by changing the configuration of the actual jack head where it's sat into the support. Normally you only get plus or minus 5 mil of movement. On there we adapted that so we had plus or minus 20 mil of movement. So that allowed the trailers to move underneath the structure as they needed to, which as it happens was also used for another part of it. The other problem that we had with this is once you get it down into position on the bridge, it comes in narrow, so it comes in inside of the existing bridge. It's then supported on stools, which are supported on beams that sit on top of the, on temporary beams that sit on top of the piers. It has to go longitudinally in exactly the right place, as every bridge needs to do, within tolerance, but certainly, within a few millimetres of where it needs to be. The Unimog, and we did trial it just for fun. The Unimog, when I tell it to stop, 2 foot later on it had stopped. So not really going to do us an awful lot of good when we want to put it into the right place. Arguably, we could have kept them moving backwards and forwards until we got it into the right place, which would have worked fine for the first span. But the second span, when it comes up to it, 200 ton hitting that next span was not really going to be the best of ideas. So what we did for that is we simply created a towing scenario using a hollow ram jack connected to the track via a MAS 50 grillage. So we quite literally brought it to the track. We had a bespoke tow bar made, the McAloy bar going through it, some 5 metres long. Once we got it to within about 300 mil of where we wanted it to be, we connected it all up so that nothing could move. Took the brakes came off on the Unimog and on the train, and we literally pulled the entire train that last 200 mil until we got it exactly where we wanted it to be. And then we did it again with the second span, bringing it to exactly where we needed it to be. That was longitudinally. Laterally, we needed the bridge to be straight, at least. The actual position wasn't as critical because we were going to actually push the main beams to their final position. Because if you imagine that we're bringing it in tight, as it is there, inside of the existing one, at some point, even, and I will explain how we did it later on, we have to then push it to their final position, to that final width. So it wasn't critical exactly where they were, but it was critical that they were straight. So in order to do that, and that's this little sketch down here, we very simply bolted onto the side of the stool a steel T that had an inclined top to it. And as we lowered the bridge down, it would pick up on whichever one it was out on, and it would literally push it to the right position. So, and as it happens, it was slightly twisted, so one pushed it one way, one pushed it the other way, and it straightened it off. And that tolerance in the jacking system allowed us to do that and allowed us to actually make that work so that we could get that into the right position. So that's how we got it down there. What we did do, because one of the things that you cannot afford to do on a 12-week blockade is to find problems within that you have to solve. So every significant thing that we were going to do, so driving it down, jacking it, those 100 mil, 200 mil to get it into a right position, pushing the beams apart to get them into the final position, the cantilever, which I'll explain later on, all of that was done on a trial slab that we had at Morpher. It was a 92.5 metre long slab. Track consisted of longitudinal timbers and bullhead rail that we had salvaged off the timber refurbishment job. So as we finished the timber refurbishment job, we literally kept 100 metres or so of this timber to one side, built a concrete slab, sat them on top, got the alignment correct, grouted up underneath them. There we got our temporary railway. And we used that to do the testing and to build from in terms of the concrete slab. And again, I do say, tongue-in-cheek, that we actually incorporated a versine error within that track, which we did. It wasn't intentional. I remember the guys coming to me in the site office saying, "Oh, can you just have a look at this and make sure it's right?" I looked down the track and I could see the kink as clear as day. And I am ex-P-Way as well, so I could see there was definitely a problem with it. And I established that the gauge was correct all the way through. So I said, "Yep, that's absolutely fine, leave it as it is," because I knew for a fact that the track that we were going to be running on was going to be very similar. So my argument in my own head was, this gives us a really good test. And it did, and it performed really well. This is a short element of the animation that just shows it being driven in. One of the things is the wind bracing on the top had to be raised up because the entire thing got brought in at higher than its final position, and it eventually got jacked down. I kind of skated over that because I'd be here forever if I talked about every single piece of temporary works. Right, so once we got the hogback sections down there with the temporary works, and you can see the temporary runway being there, that's the blue section. All of the grey sections are all temporary works. The grillage that you can see running through the centre, that's all temporary works. That was simply to keep everything together, basically. Acted as resistance for when we jacked them apart. It also acted as our access point. You can see the timber internally and the timber on top, so that was basically a walkway that we could then walk right across the bridge as we were doing the demolition. So when we come to the demolition, what you had was beams coming off the underside of the runway, and the runway beams that then had macaloid bars dropping down to a clamping arrangement on the top flange. Every one of the 23-ton sections had 4 of these. So basically, we would bring this in, connect it all up. Once everything was connected up, the demolition crew could literally cut it into the 7 sections. They didn't have to wait for anything to be dropped or lowered or for us to do anything else. They literally went from start to finish and just cut the sections up, basically. We did start, obviously, dropping them as soon as we could, but they just kept on going, and that was the one advantage that we had with that system. So they're initially bolted to the underside. As you can imagine, some of the sections have to be moved longitudinally before we can then lower them down onto the pontoon. The gantries are bespoke. They are specifically designed for this, for nothing else. Each one of them had 4 10-ton hoists on it, completely remotely operated, so the guy could be absolutely anywhere with a full remote control. He could be down on one of the piers, he could be on the walkway that we had above, he could even be actually on the thing itself if he wanted to be, which he never was, to be able to do all that. Now, with these beams coming out and being above the top flange of the existing, when you want to move it, having picked it up from the existing, those beam ends were in the way. So again, part of our temporary work system, we actually developed a hinge system for those. So they would stick out, they would hold the bridge sections. Once we took a hold of it with a gantry, we would undo the macaloid bars. We would then undo the bolts and then just hinge them back in, basically, so that they were out of the way. And the advantage we had with that was that made it quick to move the sections, but it also meant that when we drove it in the first instance, they were pulled in so they didn't clash with anything. And then once they got into position, they were just swung out, bolted up, connection made so that we could start doing that. We then transported them to the beach, which I'll show later on, where they were cut up. And they were cut up with shears rather than burnt up, because the beach is in Barmouth itself. It's just next to the harbour. It's not what you would class as the main beach in terms of the public, but public could have still went there. It was obviously fenced off for our works, but we still didn't want to be burning and having the smoke and debris from the burning from that. So that was cut up with machines. The removal of the ring beam, which I will mention again later on, and hopefully show you on the video, depending on how it comes across, is the original mechanism for swinging the entire swing span bridge consists of a ring beam, which is 7.5 meters in diameter, 17 ton in weight. When we removed that, the gap that we had between the underside of the new bridge main beam and the top of the cowling, which simply acts as a decorative feature so that people don't look at it and it protects it from the weather conditions and such like, was 40 mil in total. So 20 mil below it and 20 mil above it in terms of getting it out. When you consider that the cowling is cast, that did cause us a few scratching of heads moments, but we pushed that. We did have an alternative, which thankfully we didn't have to take, because it would have took more time, but it did come out, and it did come out very well, to be honest. So I'll stop talking about the hogbacks for a moment. Bridge 42, the two flat approaches. So again, as I said to you before, that was a relatively straightforward element, in so much as that we used TXM crane, which was the largest crane that we could get on there. There are larger cranes, but those larger cranes are greater than RA5, and therefore we couldn't have got them to the structure. That's why we couldn't use them. So capacity-wise, he was fine for the most part. Reach-wise, we had a problem. For the dismantling, it was relatively straightforward. The problem that we had is on Pier 1, and I'll point with this as well so that people can see. So on Pier 1, this is Pier 1, you've got that crosshead beam. He had more than enough capacity to pick it up. It was about 3 to 3.5 ton in terms of weight, but he couldn't physically reach it. He couldn't reach the old one from the abutment, and he couldn't obviously reach to put the new one in from the abutment. So what we did there is we had a series of gallows brackets either side of Pier 1, one set on the south that we actually, before we demolished, and this is going to get really complicated for everybody that knows about bridges. The northern span, this span here, is span 2. So from the abutment to Pier 1 is span 2. From Pier 1 to Pier 2 is span 1, because the span numbers go with increasing mileage the way they should do, and for reasons I'm yet to figure out, the pier numbers go the opposite direction. So bear that in mind. So when we demolished span 2, see, and that straight away. We demolished span 1. We then put the new crosshead beam down onto the gallows brackets. We moved back, demolished span 2, the northern span. And at that point, once we remade the plinths and done all of the stuff that we needed to do on top of Pier 1, we actually just slid the new beam into position. We kind of got into a bit of a groove for sliding beams, to be honest with you. So we actually slid that into the new position. Prior to that, we had to slide the old one closer to the north abutment in order for the crane to be able to pick it back up again. And putting the new ones back, the weight and reach that he had for the span 2, the first span, the northern span, he didn't quite have enough. So we actually made that with some of the diagonals missing, and then we welded them in place once they'd been put on. And again, the structure itself is RA5. The rail bearers themselves should have been RA7, according to the assessments. We only needed around RA5, a little bit of a percentage there, but around RA5 is what we needed to operate the TXM crane. Once we put that dance floor that you can see there on the photograph up and had a good close inspection of the rail bearers, or the support for the longitudinal timbers and the rail bearers, we found several of them in a condition that we knew was not going to be capable of taking the crane load. So we had to incorporate temporary works to bring that load back into the cross girders in order to simply lift from them and then immediately remove that and then continue with the demolition, which was curious, but it was fine. It wasn't too much of an issue. Oh, hello. Try that again. So here you see the demolition that I've just talked about. So the 23-ton sections being lowered, and at the same time the TXM crane taking apart the bridge 42. Obviously, a little bit of artistic license. We didn't just lift them straight through that girder. That was all taken apart. So it's like. And again, the gantry was designed obviously not only just to lift up and down, but also to lift and move at the same time. There's that ring beam going up. I remember talking to TGP designer David Dawson, and he made the comment that when we took the ring beam out, we took it the other way, and on his drawings he actually showed it going the other way. It didn't make any difference, but I remember him commenting on it. So we've now got the new main beams with all of the temporary works on top of them and the structure in between the two, but they are narrow basically. Yeah, they are not to the width that they need to be. They need to be moved approximately 963 mil east and west, basically, so out over. That was performed using a series of push-pull jacks, 8 of them in total. Each one of them was a 20-ton jack. We didn't need anywhere near that type of capacity, but they were used purely for the stability element of the main beams. Can you imagine you've got a 40-metre beam? She's some 4 meters high at the maximum. In fact, more, probably slightly taller than that, actually, thinking about it. And we're going to push one apart at a time. So the beams underneath, the temporary beams underneath that they were sat on, once we took all away the old structure and the old bearings and such like, we had an extension put onto those. That extension included stainless steel running section, and we had a PTFE shoe bolted to the underside of the main beams, and we basically pushed it the 963 mil. It's plus or minus because there was tolerances in there, but basically it's 963 mil. So we disconnected an awful lot of steel work, pushed it out to the final position, and then reconnected a lot of that steel work, and then pushed the opposite one out at the same time. All of the lateral steel work was designed to either be removed because it was no longer needed, or to be extended during that thing. And the gantries themselves, which weigh in at just shy of 10 ton each, were also designed telescopically. So when we pushed them apart, the gantries just simply came with it. So that we didn't have to take, because originally we thought we might have to take them off, adapt them and put them back on again. But we just simply left them in place, put them right in the middle, pushed it apart, and did it that way. And I don't know whether video is coming through to those people on the Teams call, but you can see there that's a little time lapse of it being pushed across. So we now get on to the cross edge that I mentioned before about Pier 2. And also a system that we also then used for changing the panels on the underside. But you've got to bear in mind with this bridge, it is quite unique in so much as the cross girders bolt directly to the underside of the bottom flange. Most cross girders in most bridges sit above the bottom flange and are bolted either to the web or to the top of the bottom flange. This completely, basically they are suspended off the bolts. We have adapted the design slightly, so it's slightly better than that, but they are basically suspended off the bolts. And we needed to get these 2 beams off Pier 2. So the way that we did that, we bolted the 2 bridges, the 2 spans together at Pier 4. So Pier 4 is here. So we bolted them together. They're actually bolted together in here. This little diamond shape that you see here, the connections here, bolted in. We only needed a very small number of bolts. TGP very reliably told me, although we did have an awful lot of holes there for the next element of the works. So I insisted that we put them all in. So each one of those connections had about 30 bolts in it, even though technically I think only needed about 10. But I went crackers with that. So we bolted them together at Pier 4. We had a jacking system at Pier 3, and we literally jacked the system up until it released above Pier 2. Once we'd done that, we locked the jacks off. We then brought the gantry across. So you've got a 10-ton gantry picking up an 8-ton beam. It then picked up those beams separately, lowered them down to an awaiting pontoon, immediately brought up the new ones, put the temporary works back on it because we hadn't slid it apart at this stage, to then sit it back down again to allow us to slide it apart. We then look at, once it's slid apart into its final position, we've got to get those cross girder panels, which include the bearers, into that position. So basically, you're basically bringing it in. You've got to put these bearers in place on the temporary beam that's already supporting the entire system. So we recreated the cantilever at 2. That's relatively straightforward. So we created that again, took the temporary works out, put the first panel, including the bearings, in, and you're able to load it back down again. On Pier 4 and Pier 5, it's a slightly different arrangement. So you've got this system where you can see on here, those two there are basically the temporary beams and extensions that hold the new bridge in its now widened position. We need to take that away and put in the new panel underneath it, which incorporates the bearing, which is what you can see underneath. So what we basically did is, with those two bolted together, we jacked the north side, as it happens, so the fixed span side up, so that the load path went through, bypassed that temporary beam that you see on the left hand side, down through the cylinder, the pier. From that side, created a gap of no more than about 20 millimeters. Literally picked up that temporary beam, slightly slid it out with the gantry system, lowered it down, picked up the new panel, brought it back in again, lowered it down onto that. And in order to do the reverse on the other side, all new bridges are designed with jacking positions to change the bearings. We use that jacking position to then jack up to change the load path the other way, swapped out that temporary beam, put the permanent beam back in, load it down. That's that first section done. It's now sitting on its permanent bearings with the cross girders bolted in, not every single bolt, but bolted in sufficiently for that to be okay. On Pier 5, which I haven't really detailed on here, slightly different arrangement in so much as you don't have another bridge to bolt onto. So we simply put some struts right the way up to the underside of the runway beams, so approximately 5 meters tall, and we jacked the runway beams and held it up slightly. That allowed us to come in, take it out, and bring the new panel in. So that then gets it back at to its final height, its final position laterally, which it already had been because of the jacking, and then we could then start installing the main decks. So then we literally then just pick these up, slide them into place. They're bolted to the underside. We agreed a minimum number of bolts that we could do. And what we did with that as well is that where we needed to, we lifted them up with scaffolding already hanging from them, so that we had instant access. Because each one of these panels had about 300 bolts in the permanent situation to put in. We only needed about 24 bolts to secure it correctly in the first instance, and then all of the rest of the bolts were there for the splicing and such like. So once that was done, and the other thing there was that those panels also were lifted with slave rail, exactly the width of the panel, so that once we actually had put them in, we had a running railway. we obviously for set of clamps to make sure that everything stayed together. That allowed us to remove the temporary works quickly by simply bringing trailers in underneath it, jacking it down onto the trailers and taking it away. And then we had a running railway in order to actually put the 60-foot seam and the guardrail in. So, and I hope the video works in some degree. What we'll do now is I'll run through, I'll hopefully not speak too much during the video. So what you'll see now on the video, you'll see the assembly of the main girders at Morpher on that test track that I was talking about. You'll see the trial move where we did that trial about 6 weeks before the main blockade. You'll then see it driving down the track. A significant thing there is that with all of our technology and all of our really good devices and such like, in order to make sure that she didn't tip excessively, we simply used the spirit level sitting right in the middle of the entire system. In order to look at that spirit level, I positioned my GoPro, pointed it at it, put it on preview mode on my phone, and literally myself and the maybe guys who were in control of the jacks watched it. And the second it started to move, they went, right, we'll just adjust that back up again, thank you, and on we go. And to be honest with you, they got to the point where they locked off one side, left the other side floating, and it pretty much sorted itself out all the way down. Once we got onto the timber structure, it was plain sailing after that. You'll see the demolition, and as long as it plays correctly, you'll notice the ring beam coming out. Got some very good footage of the ring beam coming out, and you'll see hopefully when I'm in there about the gap. You'll see the siding of the main beams coming out. You'll see the cantilever section. The cantilever section is some very good photographs of the cantilever section, the one that I had on there, but also from Barmouth itself, where you just got this bridge just sitting with a 2.5 metre gap beneath it, and we're still running around with 10 tonne of gantry and 6 tonne of panels being lifted up. You'll see the reconstruction of the of Bridge 42. You can kind of blink and miss it when you see the pier, the crosshead pier being moved, slid back into position. You'll see the welding and such like, and then obviously you'll see the installation of the permanent way at the end. And I'm very much hoping that it works. I can't remember if in all that hassle when I put the music on for those people who are watching on Teams. How am I doing on time? Because if people want to ask me any questions while it's on, that's fine. So the bridge sections came in thirds. It was originally designed as fifths, but carvers worked out that they could actually bring it in thirds, so they brought it in thirds in the end. You see the rivets along the top, on the top flanges there. So you see that obviously the temporary track that we laid, we built it at the width that it was then going to travel down. So literally we built it in its entirety, took it apart and then put it back together again as the 3 different sections. There's an awful lot of use of ratchet straps on this contract, to be perfectly honest with you. So holding an awful lot of that down, and it's designed, it wasn't just us throwing it in there for the fun of it, it was all designed to be done that way. So yeah, the blue beams are the runway beams for the gantry. And you can see in the distance the wind bracing that's been raised. So this is within the blockade now. To our knowledge, 200 tonne of bridge hasn't really been driven down the track like this before. There has been a job in the 80s that was a little bit similar to this, but not quite to this extent. There's my phone. As you can see the jacking system there. So an awful lot of the stuff was already in the bridge, even though it wasn't going to be used for weeks, just to save us that bit of time in the actual blockade itself. You can see it coming in, you see the stools that it sits down on. So that's the gantry being lifted in whilst we were still bringing in the section, and obviously the section's been cut. You see the old handrail there on the outside? That's the wrong view from this side. But when it comes back to the other side, you know, it's still there. There you can see the old handrail there, which is it's highway handrailing. Just bear that in mind when you see the end product. Again, even the ratchet straps holding it in place for stability were all designed from the pontoon's point of view. The gantries we named Henry and Benjamin after the original designers of the bridge. See the ring beam in center there. So this is the ring beam being removed. See what I mean about the gap? I hope this is playing well on the things. It'd be awful if it's not. If it isn't, I can share a link for people to look at it.
I think we've got a few thumbs up.
All right, that's good.
It's only a tiny bit generally for me. So.
All right, good. So there you can see us cutting the sections up on the beach. Again, it was logistically it was interesting because we could only move anything at slack water, so there's about an hour opportunity to move things. Generally at high tide, we then bring it into the beach and let it beach on the beach, and then come in at low tide to dismantle it. So there was an awful lot of planning around that. So you can see the sections, there you go, the demolition section there. You see that get slid across at some, there you go. The ducting that you can see there is the fibre optic cable, so that we still always had a continuous path for it. And there's the slide out. See the sections missing there on that first span that was being lifted in, and then them being welded back in again. So these are the panels being lifted in. So this panel here was one of the panels that goes above one of the piers, so therefore it didn't have any scaffolding on it, because the scaffolding was already in existence around the piers. And those little upright lugs that you can see are the change to the design, because they go in between the inverted T's, and then they have horizontal bolts in them, as well as the vertical bolts, which is where the design is improved slightly in terms of the fixity. You see there, obviously, with it coming in with the rail. And these are the sections of scaffolding. So that scaffolding was designed to take the weight of the panel sitting on it from the pontoon, but then also to act as a suspended scaffold once it was picked up. We had neoprene pads at the connection points to avoid damaging the new paint. Whilst all that's going on, we're obviously still rebuilding Bridge Point 2, which almost was a sideline, which in any other situation would have been an entire job all on its own. We did comment more than once that it always appeared that way, that it was just something else that we were doing, but in reality, you know, it's a major job all on its own. The guardrail sits on a combination of Vosler wherever we could, and then these bespoke 4-foot sections in there. The Ram was very keen that we had as much as we could a clear run through the 4-foot. It's all jointed across the track. You see the splice joints underneath there. This is where I was saying there was over 300 bolts per panel to be put in, which is why we needed that instant access to put all those together. And the scaffolding below allowed us to put that temporary handrailing up so that we could then fit the permanent handrail on the new deck, the new timber decking there. This is the adaptation of the timber section, slight realignment. This is the permanent handrailing, the new handrailing you can see there. And then once that was all done, we took all of the temporary works away and put in the new wind bracing. Again, there's a sequence to that to make sure that there's no issues in terms of any movement, such like. And the scaffolding underneath was designed so that we can encapsulate it, so that we had at least a bit of protection from the weather in order to finish the bolting up and finish the painting of the bolts underneath. Of note, though, we are still touching up the painting now. We handed it back on the 8th of December. But that's just a combination of the amount to do and weather. That's our compound in the background there, you can see, with the square building, rectangular building. I think I'll get this shot. So, questions? If you've enjoyed that, and yeah, any questions either in the room or on Teams?
Yeah, we got a question online from Les. So if anyone wants to ask a question online, feel free to put your hand up or pop it in the chat. And yeah, in the room, raise your hand. So yeah, we got one from Les.
Yeah, hi Steve. Sorry I couldn't be there. I was planning to attend in person, but I couldn't make it because of work commitments. But yeah, fascinating talk. I was just going to ask you, you mentioned that a lot of the track was renewed before you transported the new bridge deck in, but a section of it wasn't. I was just wondering, on that section that wasn't renewed, did you have to do any fettling works or strengthening works to the track to make it good before you trafficked it with the bridge deck?
No, we inspected it. We had our track CRE, who's also a handback engineer, run through it all, make sure that he was happy that there wasn't any particular issues. I think there was a few keys that you might have had, put back in and things like that. But yeah, it was actually, it was good enough for what we needed. Axle loading wise, we weren't putting it under any more than RA5, which is what it's capable of anyway. So from that point of view, we didn't need to do anything major to it, thankfully.
Thanks.
Okay, got one from Carl Baker.
Thanks, Steve. Excellent presentation. The videos were really superb. Really brought the presentation to the visual part of it. So it's great. I've been following this job on social media, so it's really nice to see it all brought together and delivered on site. Was it Pandrel Vipers you put on the new deck with flat bottom rail?
Yeah, it's Pandrel Vipers. I just noticed that John Booth is there. Yes, it was Pandrel Vipers that we put on the new deck.
And is it still bullhead on the timber sections then?
No, it's flat bottom on the timber section.
Oh, it's all flat bottom now.
It's now all flat bottom all the way across. Interestingly, the guardrail on the metallic is bullhead, whereas the guardrail on the timber is flat bottom.
Yeah,
that's because
a slightly off project question for you, Steve. Is there any plans to improve pedestrian and cycle access off the north end of the viaduct into Barmouth town, because it's a nightmare at the moment?
I'm aware of the BVAG organisation with Jamie Brooks there. We've had a lot of communication with him over the years. And I know that they're not really any further forward than the first time I spoke to him back in 5 or 6 years ago. So I would say probably not.
Okay.
And I appreciate what you're saying about the end of that. As you come up onto the road, it is not the best.
No. Thanks, man. Thanks, appreciate that.
Do we have any?
I'm going to ask you, during the works, did you ever measure any movements of the piers at all?
No.
None at all?
No, none at all. Conversely, when we did the timber one, there was an awful lot of movement with the timber one, generally vertically with the timber one, because again, with the timber one, we held them laterally, longitudinally and laterally to make sure that there was no movement there. But we did find on the timber that there was vertical movement, depending on what plant we had on and what state of tide we had. But in terms of these piles, we didn't register any. I mean, and we were monitoring them, but we didn't register any actual movement on any of them, or the abutment for that matter. And the abutment was a concern because we ended up putting 7 rock anchors into it. So,
how did you determine so those piers? Obviously, at this point in time, then you've got this very long viaduct, then transferring all of its lovely forces through into all of them in the way that it was designed to, and then you've come along and cantilevered off the top of them. How did you determine that they were going to be fine?
Pier 3, which is ultimately what we were cantilevering off, is the cluster of 4. TGP had established that from a longitudinal load path point of view, that was the main anchor for the actual viaduct itself. So they were quite happy that in terms of the forces that we were incurring, that it wasn't going to see anything more than it would have done through braking and traction generally. Anyway, and you've got to bear in mind that from a cantilever point of view, there's not a huge amount of longitudinal load there. Yes, we would pick up and move back, but it was still being resisted by its connection to fixed span and its converse connection back to the thingy. And even at that point, we were connecting the end of fixed span directly to the track. So again, ratchet straps, wonderful device. We had loads of them. And we literally connected it all through so that it was still tied to the track right the way through, all the way beyond up to the cantilever as well.
So in reality, it was quite useful as being quite a long viaduct.
Yes, because it performed a very good anchor in terms of that, and we used that system when we did the refurbishment of the timber one a few years earlier, because the stability wise for what was left, because we cut it in the middle and we worked our way back, which was based on that anchorage back using the track.
So because the thing that I thought was most interesting is the amount of extra weight that obviously, because you basically got the bridge on there ×3, because you've got the new part, the old part, and the stuff and the rails sat over the top of it all, and all the other gubbins attached.
Yeah, not quite 3, I would say.
Well, not quite 3.
Yeah, we did, and there was a specific sequence for the work for the demolition initially on the swing span to not overload Pier 2. So we had to take that apart in such a way that it wasn't seeing too much load specifically for that reason. After that, everything else they were more than happy with in terms of the weight that we were putting on it compared to train loading. TGP were happy that they could prove that there wasn't going to be an issue in terms of that.
Left field question. Your compound's it was sat just behind a lovely levee.
Yes, it was.
I assume that's still part of the SSSI.
No.
Ooh. Oh, it was adjacent to the SSSI then.
It's actually a little bit further away than you think. You would think that the levee would be the start of the Triple SI, but it's not. It's about 25 metres towards the sea from there, to be perfectly honest with you. All of the work was subject to marine licence, which includes a FRAP anyway. So yes, we were working adjacent to it, but not actually that adjacent. When you look at a map, our compound sits in a field that is a white bit compared to everything else being Triple SI. It's quite comical, really. It was a lack of choice almost, because you couldn't put it anywhere else. But yeah, we had, we've been there a long time, both for the timber one and for the metallic one. We had, as part of the marine licence, the ability to go on to the salt marsh. There's a road that goes around the edge of the salt marsh, and if you've been there, you'll know what I mean. Comes over the levee, goes right at the cliff face, and then along the river. And we have permission to go across that with machinery, all the way down onto the beach itself for the timber one, but also as part of our works for this as well.
So I assume you need planning permission to have used that bit of land, because I assume that wasn't on the railway originally.
It's not so much planning permission, because it's a temporary arrangement in there. So everything we put in, which was considerable, there's several thousand ton of stone that we put in there to create that. Because if you've been there, you'll go. It's a swamp basically on that side of it, and we had a 500 ton crawler crane in there, and the full trial and all the rest of it. So we had 700 mil of reinforced stone in there that we have now dug back out, just to leave it back as it was.
So did you have any requirements for what you have to place back other than just dig it out?
Well, no, because we never took anything off. So we actually laid straight on the top of it basically, and then as we dug it back out, we just bulked up what was left beneath. So basically, yeah, we've just left it as it was in essence, and it'll reseed itself within the next year or so. Any other questions online? Carl?
Yeah, sorry, Steve, I forgot to ask. Did you lose much time due to adverse weather conditions?
Yeah, we did. There was 4 named storms that happened throughout the 12-week blockade. We lost a total of 17 days, I think, Gareth. I can see you're on there, so I know you'll remember more than I will.
19, Steve, unfortunately.
Can't believe I was wrong. Right, so we lost a total of 19 days, but because we always anticipated that we would have that, the original programme didn't include Sundays, for example, so we always had Sundays as a backup. The work itself, when we installed the panels, we literally installed them with the bare minimum of bolts, and then as soon as we had bad weather, we would drop back in and then bolt them back up again. We wouldn't waste our time bolting them all together whilst we had good weather windows, because we knew, especially as we're getting to that point where we were putting them in, towards November, mid-November, that we would get stopped. So as soon as we got stopped, we would then continue back on with other activities and such like. And we handed back. We actually handed over on the 24th of November to Colas and Network Rail, who then renewed the track going through the tunnel, so the 300 metres, and it was successfully handed back on the 8th of December.
Excellent, thanks.
Now we just need to electrify it.
Good luck with that. I'd like to see you electrify through that tunnel. No.
Just quite a simple one for me, I suppose. What's the anticipated asset life of the structure?
So all of the new steelwork is designed for 120 years, as all new steelwork is. Any steelwork that is bolted to new, in my experience, is generally 50 to 60 years. But to give you an example, Piers 1 and 2 are original from 1867. The rest of the piers are 1902. As part of our works, we had to drill into those and fix new steel quite a lot, as it happens on Pier 3 for particular reasons, but obviously with the temporary works and all the rest of it. We performed pull-out tests on the concrete. We performed Smith hammer tests on the concrete for the top for the proof of the bearing arrangements, and it passed without problem at all. Any of those situations. 1 and 2 is cast iron, 3, 4 and 5 are wrought iron. They're actually in very good condition. They don't look it, they're very pitted. The cast iron has quite a lot of cracks in it, and there's a lot of banding around it. But other than that, it's actually in pretty good condition. The thickness of the steel, especially the wrought iron, was 30mm plus. I remember because the guys were complaining about the fact that they were having to drill through it in order to then drill into the concrete. So yeah, lifespan, I can't see any reason why you wouldn't get 120 years out of it again, to be perfectly honest with you.
Have you, obviously this is grade 2 style listed structure, so quite a lot of rules and laws associated with it. Were you able to build in any ways to enable the structural team and even the track team to have better access for inspection and examination? Or has it gone back to how it was, which was you have to now try and access a bridge over a estuary?
You still have to access a bridge over an estuary. I mean, the couple of points that I would say on that one is that I personally would never have walked over the bridge before we started doing the reconstruction. I'd walk over the track elements of the bridge and stand on the way beams, the longitudinal timbers. But the condition of the deck was such that you wouldn't want to do that. Obviously now the deck is fine. On the timber one in particular, and I know we're not really talking about that, but on the timber one, Network Rail saw and got approval to change the timber walkway on the downside, on the seaward side, to a GRP. Because what would happen is, because it wouldn't be walked on very often, you'd get that green, well, it would be lethal, literally lethal, and I know from experience it's very lethal. So they got permission to change that. So from a track walking point of view, they can walk on the down set very, very safely now. All of the new handrail, it's all new handrail on that side as well. The actual bridge itself, from an access point of view, nothing has changed in that respect. So it's safer because it's new, but actually it's exactly the same in terms of the spacings and all the rest of it.
So there's no access track down to the bearers then?
Oh, on Pier 3 there is. I mean, there was anyway, to be honest with you. There was the means of getting into the swing mechanism previously. We haven't replicated that. We've actually changed it so that you come in at track in the cess, and there's 4 points of access in the cess, which allows for better emergency egress as well, because what was there only was one way in and one way out. So when we were doing our work, we actually cut holes in the deck, covered them with GRP, which was hinged, so that we had that. So yeah, the access into Pier 3 is much better. The access for the rest of them is exactly as it used to be, basically. I think that's.
Questions or anything? Well, Steve, I think that was fantastic. I appreciate the complexity of it all. Essentially, at the start as well, where you noted that there's 50 individual items and temporary works, and you've essentially given us the most significant parts of it all. The animation and such all the way through as well. I can understand how that's been a massive help to the construction team as well. But I was very interested. And overall, it was just fantastic talk, technical talk through it all and everything, understanding of it all. I think it was great, pretty much. Pretty much ask anybody in the room and people online as well. You can unmute your mics and thank Steve in the traditional way. Cheers. Thank you.
Thank you very much. Oh, there we go. Excellent. Thank you very much. If anybody wants any more information of it, please feel free to email me or via Pete.
Yeah, brilliant. Thanks for dialing in, everyone, and thanks again, Steve, for presenting this fantastic presentation. Look forward to seeing you all online next month. Thanks, everyone.
Excellent.
Thank you very much. Thanks. Bye.
All right. Thank you.
Thanks.